Hello, my darlings. We are looking at notes for solving simultaneous equations by substitution. So substitution is when we replace a variable in one equation with the other equation. So for example 1, solve by substitution. This first equation right here is already in the form x equals. And we always want one equation to either be x equals or y equals. So what we're going to do is we're going to take what the x equals and plug it into the second equation. So I get 2 times the quantity negative 2y minus 7 minus y equals negative 9. And now the x's are all gone, so now we can solve for y. So I'm going to distribute the 2. So I get negative 4y minus 14 minus y equals negative 9. I'm going to combine my like terms. Negative 4y minus y is a negative 5y. And if I add the 14 to the other side, I get equals 5. Divide both sides by negative 5, and y equals negative 1. And then we also need an x, though. We're solving, so we're looking for a point of intersection. So I'm going to take that y value and plug it back into this first equation. So I get x equals negative 2 times negative 1 minus 7. 2 minus 7 is negative 5, and you always write your solution as a point. I will deduct points if you do not write it as a coordinate pair. So our solution is the point, negative 5, negative 1. Alright, so second example. The second equation right here is already in the form y equals. So to me that's the easiest one to use because I can plug the 3x plus 6 into the first equation, which gives me 4x plus 5 times the quantity 3x plus 6 equals 11. I'm going to distribute the 5, so I get 4x plus 15x plus 30 equals 11. Combine my like terms, 4x plus 15x equals 19x. If I subtract 30 to the other side, I get negative 19. Divide both sides by 19, and x equals negative 1. But again, we need a point, so I'm going to take the negative 1 and plug it back into this equation right here for x. So I get 3 times negative 1 plus 6. Negative 3 plus 6 is 3, so our solution is the point negative 1, 3. Right. Example 2 is very similar, except that neither equation has an x or a y by itself, so that's the first step. And I always try to find ones where the x or the y has no number in front. Like right here, this y, there's no coefficient. So all I have to do is subtract the 2x, and I get y equals negative 2x minus 2. And I can now plug that into the first equation. So I get x minus 2 times the quantity, negative 2x minus 2, equals negative 6. So I'm going to distribute that negative 2, and a negative times a negative, remember, is a positive. So I get x plus 4x plus 4 equals negative 6. Combine like terms, x plus 4x is 5x. Subtract 4, negative 6 minus 4 is negative 10. Divide by 5, and x equals negative 2. I'm then going to take this x value and plug it in right there into that x. So I get y equals negative 2 times negative 2 minus 2. 4 minus 2 is 2. And again, write your solution as an ordered pair. So our solution is the point negative 2, 2. One more. I'm going to go ahead and take this second equation, and since that x right there has no coefficient in front of it, I'm just going to add the 3y to the other side, so I get x equals 3y minus 3. I can now substitute this into the first equation right there for x. So I get 3 times the quantity 3y minus 3 plus 2y equals 13. So I'm going to distribute my 3. So I get 9y minus 9 plus 2y equals 13. Combine my like terms, 9y plus 2y is 11y. Add the 9 to the other side, and we get 22. Dividing by 11, y equals 2. But again, we need an x and a y, so I'm going to take that 2 and plug it in right there for y. So I get x equals 3 times 2 minus 3. 3 times 2 is 6. 6 minus 3 is 3. So our solution is the 0.32, and that finishes up the first set of notes.